Today we're going to be talking about solving systems of equations by graphing. And our first topic is systems of linear equations. We need to define what a system of linear equations is, and it is a set of two or more linear equations containing two or more variables. Now what's going to happen here is you're going to be able to solve two equations at the same time, two linear equations. And what we're going to do is start off with being able to figure out if an ordered pair is a solution of a particular system. So I'm going to give you an ordered pair, and we want to substitute that ordered pair into two equations for x and for y and actually see if it is a solution of both. So let's start by looking at the system 2x plus y equals 5 and negative 2x plus y equals 1. We want to see if the point 1, 3 is a solution. So 1 is your x and 3 is your y. We're going to plug those numbers into our equation. So we're going to have 2 times 1 plus 3, and we want to know, does that equal 5? And indeed it does. So it is the solution of the first equation. So now let's do the same thing with the second one. We're going to plug 1 in for x, so we're going to have negative 2 times 1 plus 3, and we want to know if that is equal to 1. Well, negative 2 times 1 is negative 2, plus 3 does indeed equal 1. So since 1, 3 is a solution of both equations, we will say that yes, it is a solution. The point 1, 3 is a solution of the given system. Okay, so yes, it is a solution. Now, moving on to our next problem. We want to know if the point 2, negative 1 is a solution of the system x minus 2y equals 4 and 3x minus y equals 6. So again, we're going to do the exact same thing. I'm going to move my equation up a little bit just so I have a little more room. So we're going to plug our numbers in. Again, 2 is x, y is negative 1, and we have 2 minus 2 times negative 1, and we want to know, does that equal 4? Well, that's the same as having negative 2 times negative 1 is a positive 2, and 2 plus 2 does indeed equal 4, so that is a solution of the first equation. Now let's try it with the second one. So we're going to say 3 times 2 minus negative 1. We want to know, does that equal 6? Well, 3 times 2 is 6. Negative 1 is the same as adding 1, and that gives us 7. And so 6 plus 1 is 7, and 7 does not equal 6. So it is not a solution of the second equation, and in order for it to be a solution of the entire system, it does have to be a solution of both equations. So we're going to say not a solution, just because it did not satisfy one of the equations. It has to satisfy both equations. Now, moving on to what a system of equations looks like graphically. We are going to solve a system of equations by graphing. Basically what we're doing is we are graphing two lines and we're seeing where they meet. So let's start with the system y equals negative 2x minus 1 and y equals x plus 5. Let's graph these equations by using slope and y-intercept. The slope of our first equation, of course, is negative 2 over 1. And the y-intercept is negative 1. So let's graph that. We're going to start with our y-intercept, and so we're going to go to negative 1 on the y-axis, and then our slope is negative 2 over 1, so that means we go down 2 places and to the right 1, down 2, right 1, and we can keep doing that. Once you see the pattern, I would definitely continue it in the other direction for as long as you can. You'll see why in just a moment. So there is our first line. We'll draw the line in just a moment. The other equation, y equals x plus 5, we can put a 1 in front of the x. The slope of that line is 1 over 1. The y-intercept is 5. So let's graph that. We'll start with the point 5 on the y-axis. And the slope is 1 over 1, so go up 1, right 1, up 1, right 1. And continue the pattern in the other direction. Now this is the reason I said to continue it, is because you notice we're getting a line. We already have one, and we can see right off where those lines are going to meet. So let's go ahead and draw in our lines. And I think we can see where the solution is. Where those two lines cross is right here. And it looks like that is the point -2, 3. And that is the solution of our system. Our x value is -2, the y value is 3. And both of those points will satisfy either equation. Now, let's move on to the next one. We have another system, y equals x, and y equals -2x plus 3. Now, we do not have a y-intercept listed in our first equation, so we know that it's 0. You can even put a plus 0 there if you want. There is no number in front of the x. Put a 1 in there. Our y-intercept is 0. So that's where we'll begin. Our slope is 1 over 1. So let's start at 0 and then move up 1, right 1. And that gives us the graph of our first line. I'm going to move this down a little bit. And once you see the pattern, continue it in the other direction. That will help you when you are trying to find out where the lines meet. The other line, y equals -2x minus 3. The slope is -2 over 1. The y-intercept is -3. So let's go down to -3. And our slope's -2 over 1. So we're going to go down 2, since it's negative, and right 1, down 2, right 1, down 2, right 1. We continue to do that in the other direction. And we do get a straight line, and we can even see before we make our graph where the lines are going to meet. So now let's go ahead and make our lines. Put arrows on the ends of your lines to show that they're infinite. And I'm going to circle the point where the lines meet. It appears to be the point -1, -1. So basically that means that x is -1 and y is -1. And those two values will satisfy both equations. Okay, so now we are going to move on with another example. Now, your lines might not always be in slope-intercept form, and for those of us who need a little refresher on what that means, remember slope-intercept form is known as y equals mx plus b, where m is the slope and b is the y-intercept. This is what you've been using right along, but that is the name that we give it. If you notice in this next system, y equals 1/3 x minus 3, that first equation is in slope-intercept form. However, the second equation of the system, 2x plus y equals 4, is not. So we will want to manipulate that equation to get it into slope-intercept form before we graph the line. In fact, let's go ahead and do that first. So basically, what we're going to have to do with that second equation to get it into the form y equals mx plus b is to just solve for y. So let's go ahead and do that. So we'll subtract 2x from each side. And we are left with y equals negative 2x plus 4. Okay, so now both of our equations are in slope-intercept form. The one we just solved for, where we solved for y, let's list our slope. Our slope is negative 2. And our y-intercept is 4. So let's go ahead and graph that line. So we'll start with 4 for our y-intercept. And remember, it's really, the slope is negative 2 over 1, so we have a rise of negative 2, which actually means we go down 2, and to the right 1, down 2, right 1. And we can keep doing that when you see the pattern. Continue it in the other direction. And so there is the graph of 2x plus y equals 4. Now let's also graph that first line, where our slope is 1/3, and our y-intercept is negative 3. So let's go to negative 3. And we are going to rise 1 and go to the right 3 with a slope of 1/3. Rise 1, right 3, rise 1, right 3. And now let's make our graph. We can already see where these lines are going to meet, which is exactly what you want. Put our arrows on the ends of the lines, and it appears that the lines have met at the point 3, negative 2. So that means that our solution for x is 3, and for y it is negative 2, which will satisfy both of those equations. Now, next, let's see how we can actually apply this. We have a